Hello, this is question 4 from the 2010 MAT. Looks like a geometry question. I do like geometry questions. So we've got a couple of circles. And what are they telling us about them? The three corners of triangle T are 0, 0, 3, 0, 1, 2, H. So the origin 3, 0, 1, 2, H. Yeah, the font's quite small on this, but I expect you're looking at your own copy of it as well, just to see what these pictures are actually saying. I've had to shrink it down a bit. So that's where H is greater than 0. Circle C has, all right, so we've just got two different values of H. We've got big H and little h for left and right pictures, but otherwise we're just changing that H value, the Y coordinate of the peak of the triangle. So that's moving it up and down as we change H. The circle C is centered on the origin radius 2. Angle of the triangle at the origin is denoted by theta. Circle and triangle are drawn with different values of h. Yes, they are indeed. Right, express tan theta in terms of h. Right, so tan theta, let's just drop down a vertical there then. So we've got opposite over adjacent. So tan theta is 2h divided by 1. So tan theta is 2h. Show that the point 1, 2h lies inside the circle when h is less than root 3 over 2. Okay, fair enough. So we just plug in some numbers then. So the point 1, 2h, the top of the triangle. So we can do 1 squared plus 2h all squared. And then if it's going to be inside the circle, it will have to be less than 4. So we're saying that 4h squared has to be less than 3. So h has to be less than root 3 over 2. Right, this is all started off rather worryingly easy. Part 3, find the equation of the line connecting 3, 0 and 1 to 8. Show that this line is tangential to the circle for a particular value of h. Okie dokie. So let's move this up here. It looks like we're getting into some proper maths now. So let's get the gradient then, first of all, then the gradient of the line. So change in y to h, change in x minus 2. So the gradient is minus h. So let's put this into our y minus y1 equals mx minus x1 format. So y minus 0 just gives us y is minus h and then x minus 3. We've got y is h3 minus x, just to get rid of that annoying little minus sign. And then, so this has to be tangent to the circle. So this means if we plug it into the equation of the circle, we're going to get one solution. So we can just make a little note of that. So let's say tangential implies that, so x squared plus h squared 3 minus x squared equals 4 has one real solution. So yeah, let's just set about fixing this then. So x squared plus h squared 9 plus x squared minus 6x minus 4 equals 0. So how many x squareds have we got? 1 plus h squared. Lots of x squared. How many x's have we got? Minus 6h squared x. And then what have we got at the end? We've got 9h squared minus 4. I'll put it in brackets just so I don't forget that that is our C in inverted commas. So our b squared is 36h to the power of 4, and that would be have to equal to 4ac. So 4, 1 plus h squared, 9h squared minus 4. God, this is a mess, isn't it? Well, we can get rid of that 4 and make that a 9. And then we have to expand all this out. So 9h to the 4 is going to be, oh good, they've cancelled. I was getting a little bit concerned about those. Minus 4, and then we've got plus 5h squared, I think that is. So they cancel, and then h squared will have to be 4 over 5. H is 2 divided by root 5, which I think is what they said. Yes, it is. Right, so, okay, a bit of work to do there, but it wasn't exactly groundbreaking stuff. Suppose now that h is greater than that, right? So it's outside the circle. Find the area of the region inside both C and T in terms of theta, right? So we've got h outside the circle. So it's going to look like this one on the left hand side then. And we want to get the area that's inside both, which is just going to be the sector of the circle. So this is going to be an easier one. I assume we're going to have to do this again for inside the circle later on, which would be more difficult. Right, so in this case, we can say that 1, 2h outside circle. Therefore, the area inside C and T is the sector of angle, was it theta? So that means we're just going to have pi r squared. So that's 2 is r, isn't it? So 4 pi times theta divided by 2 pi. So 2 theta. Okay, so that's that one. Right, running out of space. Part 5. Now let h equal 6 over 7. Show that the point 8 over 5, 6 over 5 lies on both the line from part 3 and the circle. Okay, well that bit's easy enough. So we just have to put the numbers in. So on the circle, so we're saying 8 squared over 5 squared plus 6 squared over 5 squared needs to be equal to 4. So, well, we can multiply through by the 25, and we're saying 64 plus 36 is equal to 100. So check, that's on the circle. And then on the line, which was this one, so they've given us h being 6 over 7. So we're saying that 6 over 5, that's our y, is equal to 6 over 7 times 3 minus x, which is 8 over 5. Okay, that all seems a bit odd, doesn't it? So 3 minus 8 over 5, so that's 3 minus 1 3/5. So that is 1 2/5. Okay, so that's our 7 then, isn't it? So 7 over 5. So 6 over 7 times 7 over 5. So tick. Okay. Hence show that the area of the region inside both C and T equals 27 over 35 plus 2 alpha, where alpha is an angle whose tangent, tan alpha, you should determine. And we've got this fact about working out an area of a triangle as well. Area of a triangle with corners, origin A, B, C, D equals that. Right, I'm certainly going to need a new sheet for doing all of this. So how are we going to do this then? We've got the h is 6 over 7. So we were saying that the line is tangential when h is 2 over root 5. So that's saying then in this case we've got h squared is 4 over 5, and here h squared is 36 over 49. Right, so that's going to be inside. That's like 40 over 50. Right, so we're definitely inside the circle. Right, okay, yes. So that's what we had to work out this bit. Right, I'm seeing how this is all fitting together now. So we've just shown that for h is 6 over 7, that point is on the line and the circle. So we've got a number of points then for kicking around here. Okay, this is fine. I think this is okay. So we've got a triangle and a sector. Yeah, we've got this set up pretty much. We're now on this point. This we've just worked out as being, what did they tell us? 8 over 5, 6 over 5. So that's 8 over 5, 6 over 5. So that's our point, which is on both line and circle. This point now, 1 plus 2, 1 comma 2h is now 1h is 6 over 7, so that's 12 over 7. And we can split this into 2 bits. So we want the area that's inside both the triangle and the circle. So we've got a sector here and we've got a triangle there, and that's going to be the two parts of this then, isn't it? So what am I trying to do? Show the area is going to be equal to that. So let's get the area of this triangle then. So the area of the triangle is using this thing. So that is equal to a half of the magnitude of AD. So this is what for these corners. So AD is 1 times 6 over 5. So that's 6 over 5. And then we take off the other two multiplied together. So 12 over 7 times 8 over 5. So that's the area of that. Oh my word. Right, so we've got, let's get all of this over 35 then. So we've got 42 over 35 minus, what's that, 96 over 35. So, and we want the modulus of this. So that is then 54 over 35 divided by 2. Yeah, half of 54 over 35. So that's 27 over 35, which is the first part of our answer. So that is good. That's the area of the triangle. Area then of the sector is going to be, so that is our pi r squared, that's our 4 pi, multiplied by some angle alpha, divided by the, divided by 2 pi. Yeah, I'm doing the fraction of the sector. I was thinking ahead of what they want with this tan alpha. So that's okay. So we can cancel those. So that's 2 alpha that we've got there. All right, so that is our 2 alpha. In fact, that's the same calculation that we did somewhere else in this, didn't we? Maybe we didn't. I don't know. Anyway, so we've got our 27 over 35 plus 2 alpha, but we can say about alpha because we know we've got this. It's going to be our ratio of these. So tan alpha is our opposite, which is the y coordinate, 6 over 5, divided by our adjacent, which is the x coordinate. So it's going to end up being 3/4. Right, yeah, that did fall out really nicely, that one. Once you can see what they've got you to do. Again, it's step by step on this. They're all following on. You know, they're putting a few hences and nows in there. But they've really led a nice path. I think that's a great question, that one is. Because again, it's a complicated problem. If they just set you off, that'd be really difficult if it was all just in one block. But they've led you through part by part. So just keep on telling a story when you're going through these questions. You know, see what they're actually representing on these diagrams. We know that we've got this point at the top of the triangle moving up and down. So try and fit every step in the question into, well, what's going on with this triangle? Or is that point inside or outside of the circle? You know, that's what they're getting us to figure out. We're getting the critical point of when H is crossing over inside the circle. We're working out the tangent line. We're working out another point on the line, an intersection point, which we can show then H is taking us inside the circle, and then work out the areas from there. So one calculation of area from the left picture, one calculation of area from the right picture. Yeah, lovely question.